Chapter 21.6 From ammonia to nitric acid. The manufacture of nitric acid from ammonia involves three stages. 1. Catalytic oxidation of ammonia to nitrogen dioxide. 4. Nitrogen hydrate, nitrogen hydrate, that is ammonia plus gas plus 5 oxygen gas, 5 oxygen molecules of gas which react in both directions to form 4 nitrogen dioxide and 6 water molecules, and with an enthalpy change of minus 950 kilojoules. And 2. The oxidation of nitrogen oxide to nitrogen dioxide, with the chemical formula is 2 nitrogen oxide plus 1 oxygen O2 molecule gas to form, which flows in one, which is supposed to flow in one direction, to form 2 nitrogen dioxide, 2 nitrogen dioxide molecules, 2 gaseous molecules, with an enthalpy change of minus 114 kilojoules. Minus means that it is an endothermic reaction which combusts energy, which uses up energy to form the molecule. If it would have been a plus, it would have meant that it is an exothermic reaction which gives up energy when it reacts. It explodes, or it warms up or heats up it gives up the energy, which can be measured in kilojoules. So an endothermic reaction means that one has a negative enthalpy change, and exothermic reaction means that one has a positive enthalpy change. The third phase is the reaction of nitrogen dioxide with water to form nitric acid. Nitrogen dioxide gas is reacted with water liquid to form nitric acid aqueous, and nitrogen oxide gas with an enthalpy change of minus 170 kilojoules. Look closely at stage 1 above. What conditions the catalytic oxidation of ammonia to nitrogen oxide? What conditions of temperature and pressure will give the maximum yield of nitrogen oxide at equilibrium? In practice, the first stage is carried out by passing dry ammonia and air at 7 atmosphere over a platinum gauze catalyst at 900 degrees Celsius. Explain how the conditions used in the process differ from those predicted in your answer to the last question. The product gases are cooled to 25 degrees and then mixed with more air so that nitrogen is immediately oxidized to red-brown nitrogen dioxide. Nitrogen oxide plus oxygen to give nitrogen dioxide. Dioxide gas, all are gases. The nitrogen oxide gas is reacted with oxygen to give 2 nitrogen dioxide gas molecules. 2 nitrogen oxide gas molecules are reacted with 1 oxygen molecule to give 2 nitrogen dioxide gas molecules. In the third stage, nitrogen dioxide reacts with water in the large absorption towers designed to ensure thorough mixing of the ascending gases and the descending solution. The final product contains about 60% nitric acid. More concentrated acid can be obtained by distilling the 60% solution with concentrated sulfuric acid. Fertilizers and explosives from nitric acid. Nitric acid plays an important part in the production of fertilizers and explosives, which consists of 25% and 3% of its production, respectively. Fertilizers. Nitrogen is an essential element which is needed in large quantities for plant growth. It is required for the formation of proteins, chlorophyll, and nucleic acids. Plants suffering from nitrogen deficiency become stunted with yellow leaves. Why does a deficiency of nitrogen cause plants to become stunted? Why does a deficiency of nitrogen cause the yellowing of the leaves? The intensive cropping of agricultural land means that the nitrogen removed from the soil must be replaced by the application of fertilizers if the soil is not to become barren and infertile. Nitrogen fertilizers are usually nitrates of ammonium salts. Indeed, ammonium nitram is the most widely used fertilizer in most countries, largely because of its very high percentage of nitrogen. What is the percentage by mass of nitrogen in ammonium nitrate, nitrate, and 14H1 or 16? How do you think ammonium nitrate is obtained industrially? Nitrogen, which contains about 20% nitrogen, consists of 20% nitrogen consists of ammonium nitrate crystals coated with chalk, calcium carbonate. It is used less frequently than nitrum, but it is non-deliquescent, unlike ammonium nitrate crystals, and it is a convenient way of liming with the soil at the same time. Explosives. Although 90% of ammonium nitrate is used in fertilizers, a large portion of the remaining 10% goes towards the production of explosives. Nowadays, virtually all explosives are manufactured by processes which use nitric acid. The formula of some of these explosives are shown in figure 21.9. Cellulose nitrate, nitrocellulose, gun cotton, propane 1,2,3 trinitrate, nitroglycerine, propane 1,2,3 trinitrate. That is 3 carbohydrates and a chain of 3 carbohydrates and 3 oxygen and 2 nitrogen dioxide ions H, which is joined at the carbohydrates. That's nitroglycerine. And then there is methyl 2,4,6 trinitrobenzene, trinitrotoluene, TNT, trinitrotoluene, methyl 2 at 2 and at 4 and at 6 is a trinitrobenzene. That is nitrogen dioxide, nitrogen dioxide, and a carbohydrate, hydrate. And then there is trinitrophenol, picric acid. That is also 3 nitrogen dioxide and 1 hydroxide, sort of a carbohydrate, hydroxide. A hydroxide ion is added, is exchanged at the other position of the carbohydrate as a hydroxide. A hydroxide ion is normally reacted at that point. All of these substances undergo rapid chemical reactions involving large amounts of gas and heat on explosion and the sudden development of great pressure. Their constituent carbon and hydrogen undergo combustion with oxygen from the nitro groups, forming the carbon dioxide and water. Their constituent carbon and hydrogen undergo combustion with the constituent carbon and hydrogen undergo combustion with oxygen from the nitro groups, forming carbon dioxide and water. Oxygen and hydrogen are reactive and exothermic, and they react with carbon. With carbon, they react to form carbon dioxide and water, or else they will directly to form water. For example, the explosion of nitroglycerine made by the action of concentrated nitric acid on glycerol propane 1,2,3 triol can be summarized by the equation 4C3H5NO3 in brackets 3 liquid to 12 carbon dioxide gas and 10 H2O water and 6 nitrogen and 1 oxygen gas. Notice that in this case there is more than enough oxygen with the nitroglycerine molecule for the carbon and hydrogen to undergo the complete combustion to CO2 and water. This is not the case with the aromatic nitro compounds such as trinitrotoluene, TNT, and picric acid, which are frequently blended with compounds containing a high percentage of oxygen, such as chlorides and nitrates, to ensure complete oxidation during explosion. It is like I will explain like A natural explosive plant or factory will be thunder. For example, the explosion of the same or similar elements in the clouds could also cause a similar expansive reaction of hydrogen and oxygen to form water, which would fall on Earth as water, but the reaction that would result in heaven will be a reaction of the compounds which react when they collide with the negative and positively charged ions, which will react to form similar explosive and expansive sounds, and will produce water as a product water, and so that I will presume that carbon compounds or carbonates or nitrates are involved in the explosive that occur during a thunderstorm or during a heavy rain or a thunderstorm, and lightning is probably the reaction that one sees. The reaction between hydrogen and oxygen is probably the reaction of lightning, which explodes and is which the hydrogen explodes with oxygen and falls on Earth as water. And there would also be an explanation for acid rain of the compounds that are also detectable on metals on metals and other elements that experience acid rain in industrial zones or industrial areas or industrial regions.